This video will talk about Multimedia Sciences Adding Multiple Vectors demo. The Adding Multiple Vectors demo includes a number of handouts and a piece of software that are designed to allow students to practice graphically adding a number of north, south, east, and west vectors by drawing the vectors on graph paper head to tail, and realizing that the graphically determined resultants are equal to those that would be calculated by adding the original vectors in the east and west and the north and south direction and calculating the final resultant mathematically. This process is enhanced by using the Adding Multiple Vectors software, which allows students to draw the vectors on the computer screen or ideally on a smartboard. Let's open up the software. So the handout is going to give the students 5 problems, and those 5 problems are also included in the software. You could also make up your own problems and put them on here if you needed more practice. As you can see, as we go down through the problems, there are more and more vectors. So let's just choose one. Let's say problem 2. And problem 2 is, let's add 500 meters south, 800 meters west, 200 meters north, and 1,300 meters east. So the first thing the students were going to have to do is to draw those vectors and add them head to tail on this vector diagram. So let's see. South is this way, so 500, 1, 2, 3, 4, 500. And then from there, we're going to go 800 meters west, which is this way, 1, 2, 3, 4, 5, 6, 7, 8. And then from there, 200 meters north. So students can get a good idea of how to draw vectors. 1,300 meters east, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What I'm doing is just holding down the mouse button and dragging. Now I'm going to change the color, and the next question would be to ask the students, well, what's the final resultant of adding up these 4 vectors? And that, of course, would be from the start to the finish. So now we have our resultant in red. And finally, I'll choose green, and I would ask the students, well, what would the components of this resultant vector be? And hopefully they would come up and say, oh, well, I would be able to get the components by adding these 2 vectors that are perpendicular to each other. And that means that this vector is the same as going 100, 200, 300, 400, 500 east. So here's the graphical results. And 1, 2, 300 south. And I'm going to make it minus 300 to represent south. Okay, now we're going to do the same thing, only instead of doing it head to tail graphically, we're going to do it by addition. And we're going to give each of these vectors a name, and they are distance vectors. So I'm going to call the first one D south 1, and it is 500, so it's minus 500. And the second one is 800 meters west. So I'm going to say D west 1. And the reason that I'm putting these vector names is I'm going to ask the students to also identify on their graph paper as they draw these to use the same nomenclature. So that would be minus 800 because it's to the west. And I guess we should be putting in the units since the units are not included. The third one is 200 meters north, so that's D north 1, and that's plus 200 meters. And finally, 1,300 meters east, that's plus 13 100 meters east. And now we should be able to add these up. And let's see, minus 500, that's minus 300 meters. And this is 8, which is 500. It's plus 500 meters. And that would be east. And so now we can see that adding these vectors up, north-south and east-west, gives us exactly the same answers as our resultant. And again, I should be putting in the units here. Finally, now that we've gotten the two components, students can go and on this sheet they will, and I give there as a page on the handout that has the sheet on it, they will draw in the two components, head to tail, and do the calculations to find the resultant. You can then look at the answer. You can see here are the values drawn in and labeled. Here is the addition in the table. So this is not what we did. This is just showing the final answers, and then this is what the final resultant would be. And then you can go back and you can start to work on a different problem. So you have 5 problems to practice with your students. You have a list of objectives. You have the handout with the 5 problems. You have the software. You have answer keys for the 5 handout problems. There's also a set of instructor notes that would give you more information and additional comments. Obviously, you can just go to the software and use the simulation here to draw vectors head to tail in any way that you want. If you want to illustrate how vectors add together, you can also just get rid of the vectors if you make a mistake. Again, you can change the color. So this is kind of a portable vector play kit that you can use for a lot of other applications as well. So that's the adding multiple vectors demo from Multimedia Science. If you'd like to find out more about the adding multiple vectors demo, go to the Teachers Pay Teachers site at this URL. You'll also find many other multimedia science software and materials for physics and chemistry, simulations, labs, games, challenges, and teacher tools. Thanks for watching.